So, hello everyone. Today we are going to solve the chapter 15 for the AoPS Volume 1. This is another geometry topic about the perimeter and the area. So, supposed to be, a little bit simple, right? Let's start with the problem 261. So we have the triangle ABC and the ADE are both equilateral triangles. Okay. So we have ABC. Okay, and you can see D is the midpoint. So with rotating this one by 30 degrees, right? Then B, this is the D. Then B to the B prime, and then also this should be like this, right? And this be the should be E. Okay, so here is the 90 degrees. So with the side length is 4, means this is 2. This is also is the 2, right? So the side length is 4. And the AD is perpendicular to BC. So we want to find the area of the common area. Okay, so we want to find a common area. So in order to find the common area, let's see. Okay, because this one rotating 30 degree is here, right? So this one rotating to here, then this side the 30 degree rotating to here, then also the center point, the D, moving to this point, right? So this is the 30. So because they are symmetric, right? The D after rotating is rotating to here, so this should be symmetric. So by symmetric, we know, okay, that this side equals to this side, right? And this angle and this angle both are 15 degrees. Okay. So now in order to calculate the area, right? So we know we can calculate in this side, right? And we can also know how could I have to use the trick? Let me think. So if we know this side and we know this side, we can calculate the area, okay? But I just want to see, do I have to use the trick? Okay, so let's assume this is the x, right? And then we have this one is let me think. Okay, this is the 60. We don't have to use the trick. Okay, so did you see the triangle of the? Let's see. This is the P. Okay, triangle B prime DP. Okay, is a 30, 60, and 90 triangle, right? So if this side, we assume this side is x, right? So this side will be the 2x over root 3, right? And this side will be the, we know this side will be the 4 minus 4 times the 2 root 3. Okay, now we can solve the x, right? Once we solve the x, we solve the area. Okay, so let's solve the x. So x squared plus the 4 minus 2 root 3 of the square is equal to the 2 over root 3 of the square than x squared, right? So this one means the 1 over 3 of the x squared is equal to the 4 minus the 2 root 3 of the square. So this means that x equal to root 3 times 4 minus 2 root 3. So means x equal 4 to the root 3 minus 6. Okay, so now we solved x, right? So the shaded area is basically two triangles, right? So the triangle of the ADP, right, is half of the 4 times the root 3 over 2 is 2 root 3, then times the 4 root 3 minus 6, right? So the shaded area is 2 times the triangle ADP is 2 root 3, then 4 root 3 minus 6, right? So it's 8 is 24 minus 12 root 3. Okay, so in otherwise, I mean, if you didn't see this angle is 30, 60, 90, you can also use the trigonometry. Okay, it's not that hard because you can figure out this line, right? And by the 15 degrees, you can also figure out this one, right? So the only thing is for the sine 15 degrees, you need to know how to do it. Is sine 45 minus 30 degrees, right? Is the sine 45 times cosine 30 minus the cosine 45 and the sine of 30. So this one is 1 over root 2 times cosine is root 3 over 2, then minus the 1 over root 2 times 1/2. So it's the 2 root 2 root 3 minus 1. Okay, this is if you want to use the trick. Okay, so this is how we calculate the sine 15 and the cosine 15. Question number 262. So we have a rhombus is formed by the two radius of and two chords of a circle. So let's draw a circle. Okay. So we have a rhombus is caused by the two radius and two chord. Okay, so this is the two radius, this is the chord, right? So they are all the radius of R, right? So this is the rhombus, and they are parallel. Okay, so we know if they are parallel, right? So if we extending, for example, this is the A, B, O, D, C, right? So we know if B, C, and AD are parallel, and also the BO equals OC, right? If we extending this line, we intersect the circle at C. They are parallel, so we know this is the arc AB equal to the arc CD, right? So AB equals CD, and also means the AB chord equals the CD chord, right? So ABCD, okay, is a isosceles trapezoid. Okay, so circle whose radius is 16. So we know R is 16. So let's notating here. and 16. Then what is the area of the rhombus, right? So you can, if you extend, you can see it clearly. Okay, you need to be able to see here is 16, 16, 16. Will you figure out the angle, right? Once you figure out the angle, then it's easy, right? So you know the height. This is the height. The height is the 16 root 3 over 2, so it's 8 root 3. Then once you figure out the height, you figure out the area of the rhombus, right? So the rhombus, we just draw a seam like parallel, and the two adjacent sides are equal. So it's 16 times the 8 root 3 is the right. So that means the key point I want to point in here, okay, is once you see these two lines are equal, normally you want to extending on the circle. Okay, you want to extend the parallel line because any parallel chord on the circle will cutting into isosceles trapezoid. This may helps you to see some relationships of the angle. Okay, so next is the question number 264. So the ABCD and the EDFG, okay? EDGF, okay? So let's draw the DEGF first. We have the DEFG here, okay? Then it has an area of 16, right? Means the side A is 16, root is 4. Then H is the midpoint. So H here is the midpoint, okay? Then of the BC and the EF. So it is the both BC and the EF, okay? Then let's so it is A, B, C, right? So you can see this is the midpoint, means this is 2 and 2 and 2 and 2, okay? And then this, if this is the alpha angle, right? And this is also the alpha angle, right? Means after you rotating the alpha, they can both overlap each other, right? So the corresponding angle is also this one, and this one is also alpha, right? So this is the alpha, so this is 90 minus alpha. And also corresponding of this line and this line, right, is also alpha, right? So, okay, so let's notate some angle first. Then this is 2. Okay, so because this is 2, right? The two sides is also equal, right? The two legs are equal. These two right triangles is congruent. So we must have this angle equals to this angle. Okay. So now this one is the, since this is the half, right? So now we want to calculate the ABH. Okay, so the area we want to calculate, okay, is ABH and this one, right? So if you can see these two area, okay, the area of the ABHFGD will be 2 of the square, right? Take out the area, one area overlap, right, is DEHC, right? The 2 of the square is easy. It's 2 times the 4 square is 32. Then okay, then DEHC is 2 triangles, right? So SDEHC is 2 of the triangle of the EHD, right? Is equal to half of the 2 times 4, right? So this one is 4. So now you take out this 2, right? So the area of the ABHFGD is 32 minus 4 is 28, okay? So you don't need to, for this problem, you don't need to see all the relationship, right? But I want to let you see the rotation, okay? You can see the rotation, all the corresponding sides have the same angle. So this is the alpha, this corresponding to this side is alpha, this corresponding to this, right? So this is alpha, this 90 minus alpha, 90 minus alpha. So you can calculating all the angles, and also we can represent this angle, right? This angle is 45 minus alpha over 2, right? So the 45 alpha over 2, so the tangent of the 45 minus alpha over 2 is 2 over 4, right? All this information, you don't need it here, okay? But if you see some other problems, you'd better see all this relationship. So question number 268. So let n be the arbitrary point on the median, okay? So this problem is simple, but there is something important I want to say, okay? Let's see, this is the A, B, C, right? And we have the midpoint of the M, so CM is the median, right? So we pick any point of N on the CM, okay? Then we want to prove the AMN is equal to the NMB, okay? So this is a common height, equal altitude model, okay? So here is A, B, C. That if we cutting anything like if we know the ratio is A to B, okay, then the area is also A to B because there is a common height, okay? So the triangle AMC is the half of the, let's see, this AT, this is the BT, right? Is AT times H, okay? Then the triangle of the BMC is equal to half of the BT times H. So the ratio of this is equal to A to B, right? Because the height is common. So here you can see the base is the height is common, right? The base is 1 to 1, so that's why these two areas are the same. The second one is you want to prove that ANC is equal to BNC, okay? There are two ways to see it. You can see the ACM equal altitude model, right? The equal to the area of the BCM. And also ANM, right? The ACM is equal to BCM. Then the ANM is equal to the BNM. So by subtract each other, right, you can see the ACN is equal to the triangle BCN. Okay, but also, I mean, if these two sides are equal, right, and also this height is equal, so from B to the distance from the B to this CM line, and the distance from A to the CM line is also equal, as long as these are equal, okay? You can prove use the congruent triangle because this side equal this side, right? And this angle equal this angle. 90 degree equal 90 degree. So based on the AAS, right, you can prove this this height equal this height, right? The CN is a common base, right? So CN is a common base, right? The ACN is the CN times this height. The BCN is the CN times this height, right? So these two heights are equal, so that's why the area is still equal. There is a Cheever theorem, okay? That means called the CEVATHM in the geometry. It means pick any point P inside on the triangle, maybe not inside, maybe outside as well. Okay, it doesn't matter. So then we connected the AP intersect BC at D, BP intersect at E, and the CP intersect at F. Okay, then what you can get is the AE over EC times the CD over DB times the BF over FA is equal to 1. Okay. So when you prove this Cheever theorem, we can see the triangle. We use the area. Okay. You can see the triangle APB over the triangle APC is equal to the BD over DC. Okay, then we use the triangle of the APB, triangle C. Okay, that's BPC over triangle APB is equal to the side of the CE over EA, and the final one is the triangle ACP over triangle the BPC is equal to the AF is equal to AF over the FB. Okay, then you times them together. You will see here is APB, APB, ACP, APC, right? BPC, BPC is 1, so you can prove it. Okay, let's take a look at the first one. Okay, then you can see the rest of them. So the APB is this one, right? The APC is this one, right? So we have a common base is AP, right? So you can see the height of this is this, right? For APB, the height for the APC is this one, right? So you can see the ratio of this one per the similarity is equal to this one over this one, right? So you need to be able to see this similar triangle here. Okay, this one similar to this one. Okay, so that's why the height ratio is equal to BD over DC. In this way, we can prove the Cheever theorem. Okay, that's the direct use of this the results from this problem. So question number 269. So we have a 3 meter and a 4 meter square. So let us draw a 3 meter square, 3 meter square. Okay, then with the center of the D, then we draw another is the 4 meter square. Let's draw this. Okay. Okay, so it's the D, E, F, G, right? So here we see we have a constant length, right? It's this one. This one is 3 over root 2, right? That's the DF is length. So in order to calculating the shaded area, right? So let's make some cuttings, okay? So let's land height of this, right? So this area and this area, right? We're cutting this one into 2 triangles, right? So we know this height is 3 over 2, right? And also this is 3 over 2. So the area is a half of the FG times 3 over 2, right? That's the first part is a triangle DFG, and the triangle DEF is equal to half of the EF times 3 over 2, right? So the give us a sense is we want to see if FG plus EF, right, is what? So if you think, okay, if we're rotating this one by 90 degrees, I mean, if this may be a constant, right? If we were rotating by 90 degrees here, right? So it's the FG and the EF is basically this one plus this one 3, right? So let's guess. Is it equal a constant 3? Okay. Now, if it is equal constant 3, that means we need to see this is the D F. For example, it's a G H I. Okay. So if we can see the GH equals IE, right? So we can prove it's constant, right? So now let's see. Okay. So we know the one side is equal, right? The triangle, the DGH, and the triangle, the DIE. Okay. We want to see the DIE and the DGH, right? We know the DH. We know the DH equals IE, right? And we know it is 90 degree equals to 90 degree, right? Okay. Now let's see another one, okay? So this square is this square is rotating some angles, right? Okay, so this is alpha degrees, right? This triangle. And if I rotating this alpha degree, this one will match here, right? So this is also alpha degree, right? So this alpha equal alpha. Then we have the angle side. Then what do we have? We have the AAS. We can have the triangle GDH congruent to triangle EDI. Then what we have is IE equals GH. If IE equals GH, right, that means the GF plus EF is equal to HF plus IF, right? So now we prove, yes, this is true, right? If this is the true, then the area is summed them together is equal to half of the 3 times the 3 over 2 is 9 over 4. Okay, then question number 270. So we have a square ABCD is inscribed in the circle. So we have a circle. We have a square inscribed this circle. Let's say it's ABCD, and the X lies on the minor arc of this, right? Such that XAB and the XCD, XAB and XCD, right? So we know the XAB equals 1 and the XCD equals 993, right? So let's see, this one is the H1, right? Then this one is equal to the, let's see, this is the A, so this is the A, right? So from the XAB, right? So what we want to trade is XAD and the XBC, right? So XAD is equal to half of the A times, let's say this is the M, then this is the A minus M, right? So M, then S triangle XBC is equal to half of the A times the A minus M. Then these two together is equal to half of the A times A is half of the A square. Okay, so we want to solve the A or A square, right? So SX XAB equal to half of the X A times the H1, right? And the S of the XCD is half of the A plus H1. So this is the 1, this is 993. So now you can see in order to solve the A, right? So we want to cancel the H1, right? So XCD minus the triangle XAB is 992 is equal to half of the A times A is half of the A square. So we solve the half of A square is 992. So this part is 992. So this is the answer. Question number 271. So the convex pentagon of A, B, C, D, and E have this angle is 120, this angle is 120, then EA and AB and BC are all 2, and CD is 4 and ED is 4. So what is the area of this pentagon? Okay, so my first thinking is I always want to make a triangle, right? So let's see which is easy to see. Okay, if we can get the whole triangle, right, and we take out these two smaller triangle, we can solve the problem, right? And another way you can see is this is 120, this is 120, right? And this is the 2, this is the 2, right? So this will be a like a trapezoid, right? Because I mean, if you think this is 2, right? This is the 120, this is 120, this is 2, this is a 2, right? Let's length the height, right? So this is the 60, this is the 60, so this is root 3, this is the root 3, right? So this point and this point to a line have the same height, right? That means what? That means this line is parallel to this line, right? If we have parallel lines, right, then this height will be equal to this height. So we can using this way to prove they are parallel, right? So if we have a parallel line here, okay, then what can we do? We have the 60 and the 60, and so we can have we can length the height here, right? So it's 2, then this height is root 3, then this is 2, right? And if this is the 2, then this is the 1, this is the 1, right? So 1 plus 2 plus 1 is 4, right? So now we have the EC equals 4. 4 for 4 is what? Is a equilateral triangle, right? So now you can see the area of the equilateral triangle DEC is equal to root 3 over 4 times the 4 square is equal to 4 root 3. Then the area of the trapezoid, right, is a isosceles trapezoid will be half of the 2 plus the 4 times the height is root 3, so it's 3 root 3. The two together is 7 root 3. Okay. So now the next problem is 277. So in the diagram, okay, so this diagram is we have a square, okay, then we have two quarter circle here. So all with one with the center of B, one with the center of A. So we have two quarter circle here. So by symmetry, right? So it's land in the middle. So it's the midpoint is M. So the of a square of side is 6, right? So 3 and 3. Find the area of the shaded. So we have this one, right? We want to find the area of the shaded. So the shaded part is by an arc of this, by a line of this, then by this one, right? So now let's see what's the shaded area, okay? So the shaded area is bounded by the arc, by another arc, right? And by this line, right? Okay. So what you can see, okay, the shaded area is equal to this part, right? Let's see, this is the M, this is the N, okay? So it's the AN, BN, AB, ABN, right? It's this part, okay? Then we take out this part, right? Let's see, this point is P. Okay, so the shaded area is this one, and this one, right? Let's take out this part. So the APB, right? APB is just a section of the arc, right? Okay, so now let's calculating to see what is it, okay? So you know the AP is the diagonal, right, of this square, right? So we know this angle is 45, right? So the APB is 1/8 of a circle, right? So now we can see the sector APB, right, is equal to the pi times the r square, right, divided by 8, then it's 9 over 2 times pi. Okay, so the next is we want to solve what is the A and B, right, on the arc. So the A and B on the arc, right, on the arc's area is equal to this one is an equilateral triangle 6 6 6, right? This is the radius, 6 6. So is an equilateral triangle plus this two small crescent, right? So the equilateral triangle is √3/4 times the 6 square is 36 plus, right? So what's this part? Okay, so this part is equal to, this is 60 degree, right? 1/6 of the circle, right? So 2, then we times 2, right? So we have the pi times 36/6 is 1/6 of the circle, also minus the 4 square root to 36. Okay, so now we can see, and this one is 12 pi, right? Minus the 9 is 18√3, then plus the 9√3 is equal to 12 minus the 9√3, 12 pi minus the 9√3. Now we solve this part, right? And we also know this, so now you can see the shaded area is equal to the A and B minus the APB, so it's the 12 pi minus 9√3, then take out the pi, 9 pi over 2, so it's 224 minus 9 is 15 pi, right? Minus 9√3. Okay, so that's it for the selected problem for this chapters. Okay, and thanks for watching. Thank you. Bye bye.